activity given on page 12. Okay, in the figure, figure is 1.31 in the textbook. AB is parallel to CD and CD is parallel to EF. Okay, AC is 5.4, C is 9, BD is 7.5, and we have to find DF. Okay, when you see this 3 parallel lines and 2 transversals, which theorem will you remember? That is the property of 3 parallel lines and their transversal. So what does the property say? The ratio of the intercepts made on a transversal, the intercepts made on the transversal by 3 parallel lines are equal to the corresponding intercepts. Same parallel lines are intercepted by another transversal, then the ratio will be the same. So what will be the equation that we'll write? So this side, that means, what does it say? That the intercepts made on this transversal, suppose we take this transversal as T1 and this transversal as T2. So intercept made by these points, which are these points? AC upon CE will be equal to the right hand side intercept, which is the intercept? That is BD upon DF. Now what is the reason? Reason is the property of three parallel lines and their transversal. That's the reason, right? According to this theorem, that is why these sides are in proportion. That is AC upon C is equal to BD upon DF. Now what is the value of AC? Value of AC is 5.4. Value of C is 9. What is the value of BD? Value of BD is 7.5. Now we have to find DF. So in order to find DF, we have to solve it. How do we solve it? Cross multiply, right? And then what will you write? 5.4 into DF is equal to 7.5 into 9. Therefore DF is equal to 7.5 into 9 upon 5.4. What do? We multiply by 10, both up and numerator and denominator by 10, and what will you get? We will get 75 into 9, decimal I have removed by multiplying by 10, upon 54. If you remember 9 tables, fast we can do, or we can take with 3 also. Okay, so I'll start with simple only. 3 3s are 9, 3 1s are 3, 5 minus 3 is 2, 24, 3 8s are 24, 3 1s are 3, 3 6 are 18. Now we have to find whether 75 is going in 3. Does 75 go in 3? 7 plus 5. How much is 7 plus 5? 12. Okay, 12. Is it there in the 3 tables? Of course it is there. 3 4s are 12. So we will cancel it. 3 2s are 6 and 3 2s are 6. Remainder 1. 3 5s are 15. Now we got, what is the number we have got? 25 upon 2. Now we have to divide 25 by 2 because 25 is not divisible by 2. We will divide it and get the decimal. 2 1s are 2. Bring down 5. 2 2s are 4. 1. Put a dot. 0. 2 5s are 10. Now we got the answer. The answer DF is 12.5. Let's revise once again the activity. In the figure we have AB parallel to CD parallel to EF. So we have AB parallel to CD parallel to EF. AC is 5.4, C is 9 and BD is 7.5. We have to find DF. So since AB is parallel to CD parallel to EF. Therefore, property of three parallel lines, which sides will be in proportion? AC upon CE, or AC is to CE, will be equal to BD is to DF. BD is to DF. We have already done it. I am just revising once again. And now we are going to substitute the values of AC, CE, BD in order to find the value of DF. So what is the value of AC? 5.4. We have got it here, 5.4. And even in the question we had 5.4. Upon CE. What is the value of CE? CE is 9. Here also it is 9. How much is BD? BD is 7.5. BD is 7.5 upon DF. And when we cross multiply, we have 9 into 7.5. Then I multiplied by 10 in order to remove the decimals on both the sides, that is on the numerator as well as denominator. So what we got? 7.5 into 9 into 10 upon 5.4 into 10. So after removing decimal, we got 75 into 9 upon 54. Then when we cancelled it, this I cancelled with the 9 tables. 9 ones are 9, 9 6 are 54, then 3 2s are 6, 3 2s are 6, and remainder 1, 3 5s are 15. So we got 25 upon 2, and we divided 25 by 2, we got the answer 12.5, and that is the value of DF. Now we go to the activity on page 13. In triangle ABC, ray BD bisects angle ABC. Now we have this BD bisecting angle ABC, this angle. D is between A and C. When it is written A dash D dash C, it means D is between A and C. Okay, and side D is parallel to this side. D is parallel to side BC. And E is between A and B. E is between A and B. We have to prove that AB upon BC, that is AB is to BC, is equal to AE is to EB. So first we will take triangle ABC, ray BD bisects ABC. Okay, so we are doing the solution. So when you have the bisector, what happens to the sides? According to angle bisector theorem, the bisector divides the side into the same proportion as the remaining sides. So which sides are in proportion? That is AB is to BC is equal to AD is to DC. Okay, we have got this first equation. The second one we are taking again triangle ABC, and we have ED parallel to BC. So which theorem are we going to use? We are using the basic proportionality theorem. So according to basic proportionality theorem, which sides will be in proportion? ED is intersecting side AC. So the sides which will be in proportion will be AD upon DC will be equal to AE upon DC. So we will write here AE is to upon EB is equal to AD is to DC. This is the second equation. What have we found in these two? They are similar. That means the first equation, the right hand side, and the second equation, right hand side, are equal. So therefore AB upon BC will be equal to this one, AE upon EB. This is what we had to solve, we had to prove, right? Now, what is the logic? When A is equal to B, suppose this is A is equal to B and C is equal to B, then what will be equal to C? Then therefore A will be equal to C. What is A? A is AB upon BC and C is AE upon EB. So now we have proved this activity. We'll see once again in the proof in triangle ABC, ray BD bisects angle B. Therefore, according to angle bisector theorem, AB is to BC is equal to AD is to DC. Okay. Now again in triangle ABC, D is parallel. So according to basic proportionality theorem, which sides will be in proportion? AE is to EB is equal to AD is to DC. Now from equation 1 and 2, what we got? From 1 and 2 we have got AB upon BC is equal to AE upon EB. Okay, so this was the activity. Watch next video to understand practice set 1.2, the first sum. Thank you dear children and God bless you always.